Electrical engineering has been making our lives easier and more convenient. This video is about one such awesome application of electrical engineering, which is inductive pressure transducer, or in layman's terms, a pressure sensor. We often need to measure the pressure of various fluids, which can be measured mechanically by various devices such as a manometer. We all know the pros of a manometer. Now let's take a look at the cons. It's not suited for very high pressures and pressures that are changing rapidly with time. They require the measurement of one or more column heights, which although is not particularly difficult but can be time consuming and irritating. Now what comes to our rescue? Electrical pressure measuring devices, which converts the measured pressure into an output signal. One such device is a pressure transducer. It uses burden pressure gauge principle, which uses elastic deformation to measure pressure. Measures pressure and high pressures that are changing with time. The pressure transducers can work on three principles: reactive, capacitive, and inductive. The basic principle of a pressure transducer is that of a much simple device known as a burden pressure gauge. Hence, to simplify the understanding, let's see how a burden pressure gauge works. When a pressure acts on an elastic structure, the structure will deform, and this deformation can be related to the magnitude of pressure. As the pressure within the tube increases, the tube tends to straighten. This is connected to the core of LVDT, which is linear variable differential transformer. Now, relating this to the working of pressure transducer, we see that as a pressure is applied by the deformation, the resulting motion of the end of the tube moves the core through the coil, and mutual inductance changes take place. The extent of core which is pushed between the coils govern the changes in permittivity of the air gap. This change is directly reflected in the output voltage. This voltage is a linear function of the pressure and could be recorded on an oscillograph or digitized for storage or processing on a computer. Now let's take a look at the applications of a pressure transducer. Wouldn't it be wonderful if the tire of your car could complain when it's feeling low? Well, a pressure transducer empowers the tire to do exactly the same. A typical tire pressure monitoring system fits within the tire and contains a pressure transducer and a transmitter that sends the information to an electronic control unit within the vehicle. Information about tire pressure and a warning when the tire is underinflated is displayed on the instrument panel. Another application is that of blood pressure measurement. Pressure transducers are used to measure arterial blood pressure, which is a relatively small pressure that varies periodically with a fundamental frequency of about 1 Hz. The transducer is usually connected to the blood vessel by means of a liquid filled small diameter tube called a pressure catheter. Thank you for watching. This presentation was brought to you by Kritika, Minaal, and Yuktisha.